Hello, this is Dr. Keith Schubert. For the intro to floating point numbers, I actually want to start by giving you a cautionary tale. This is a program that I invented while I was doing my doctoral work to illustrate the dangers that is inherent inside of floating point numbers. And it's a pretty simple one. It's got three includes up here, just IOStream, IOManip. These two together allow me to do output and show as many decimal places as I want, basically, of the number. And CMath I have included to give me square root and POW and stuff like that. So, these are just standard libraries. I'm using namespace standard that's going in. And then all we do, here's our main program. I declare some variables as doubles, pi, e, and result. And then int I, this is just going to be for the number of iterations. Pi and e are just for your reference. So e I calculate by doing x of 1. So that just gives you standard e. Pi, this is actually a really good way to get pi. A lot of people put in 3.1415 or whatever they remember of pi, but it's not as many digits as the machine can hold. Arctangent of 1 is, it gives you pi over 4. So when you do pi over 4 times 4, that just gives you pi. So this is a nice way, and these functions are guaranteed to calculate to the machine's precision. So this gives us pi to the full precision of the machine. So then what we want to do is we'll set our variable result to initially pi. So we're just saying we start with pi, and then we're going to do from 1 till it's less than 53, so 52 iterations. And, our result is just the square root of result. So we're just going to take pi, and we're taking 52 square roots. And then we're going to take the same thing here, and I do 52, so you'll notice it's the exact same number of iterations, and result is going to be result squared. So I did 52 square roots, now I'm doing 52 squares. Now, in human thinking, we should take a look at this. If I had infinite precision, I do 52 square roots and followed by squaring 52, they would cancel each other out, and result should still hold pi. So all I do here is I just set the flags. This just sets the decimal point, sets it as a fixed thing, gives me 16 digits of precision, so that just shows 16 decimal places. I output pi, the result in e, so you can look at the result in between. We said result should be on the pi side, so you can imagine what I'm doing here. There's going to be a result coming up, and then of course I just tell it to return. When you look at it, here's pi. If you look at the result, it's almost exactly e. I mean, we don't differ until here, and even then it's not a gigantic difference that's going on. So what you look at is you're seeing e to something like 6 or 7 decimal places. I think I'd actually calculate here. Okay, so 7 significant digits of e. You would look at that and say, oh my goodness, if you had just seen this number by itself as the result of some calculation, you would think that you had e. Now the reason why it actually works goes back to the formula for calculating e. It turns out that essentially I knock out all the precision and calculate it back, and that series of squares ends up being essentially the same as the definition of how e is calculated. And I kind of disguised it. If anybody's really interested, I wrote a paper on how this all works, and you can see it on my website, or you can come by, and I'm happy to talk to you. My point on here is not necessarily to show you every way that this is calculated, but rather something that you would think in full precision should give you the answer back, which it should. when you go to a finite precision, can actually give you very drastically different answers and can give you things that you would never suspect was anything other than what you calculated, even though it should be something very different from what you calculated. So this is kind of my cautionary thing on here, that you should know what you are trying to calculate, at least in concept. What is it supposed to give me? So that when you see a result that is not in keeping with it, that you can identify it quickly and be able to um, go in and try to figure out what's going on. Because that's the only way you'd be able to flag this error. So I hope this gives you kind of the motivation for it, and I will follow this up by a class talk or a little section talking about actually how this is now calculated.